When you think about making your home more sustainable, you may think about this, a light bulb. With Growing Green, we often turn to these small little changes to reduce our energy consumption and our impact on the environment. And while it's good to make sure you've got up-to-date light bulbs and that you turn them off when you don't need them, it's actually the design of our homes and apartments that has the biggest impact on energy efficiency.
Something that I wish more people knew about building sustainably is that it's not as expensive or challenging as they may think. There are ways to make changes that can make your home much more environmentally conscious without it being this astronomical price tag.
Architects like Sienna Shaw are building with these techniques to bring a household's energy demand down by 80% or more.
The house that's standing behind me is a project that my partner Brian and I did. Gosh, it was like one of those dreams, right? We don't have the money to buy a property and build our own house right now, but we can buy a trailer and we can build our dreams basically, but at a much smaller footprint, right?
Before we get into how Sienna builds environmentally friendly homes, let's first get into how temperature is actually stored in a house and how it can be lost.
If you had a cooler that you were trying to keep everything inside cold, but you had a bunch of holes and you were out in the middle of the desert, the ice is going to melt inside, right? I mean, it's the same sort of idea, but if it's completely sealed up and you keep it closed, it's able to maintain that temperature for much longer.
So when the heater's blasting, if the house is full of holes, all that hot air is just escaping outside. This is obviously a waste of energy and results in those harmful carbon emissions. Every building has what's called a building envelope, and this is basically that sealed cooler. You ideally want a building envelope that doesn't leak, at all. Think about it. Houses used to be built with temperature as the top priority. Before we had energy-guzzling mechanical systems to change the temperature to whatever we wanted, builders had to use natural forces and clever engineering. So houses were basically thermal batteries, storing heat in case it's needed later. And don't get me wrong, it's great that we now have the technology to heat and cool rooms at the touch of a button, because I'm cold all the time. But air conditioners and heaters take so much energy to work. And in fact, more than half of the average household's energy consumption is used just for heating and air conditioning. But what if we built homes so they didn't need tons of power to be constantly heated and cooled? If we didn't have to rely on these machines, we aren't putting those damaging carbon emissions out into the atmosphere, which is good, really great. So the technology has been getting more energy efficient over time. Think about those light bulbs and double pane windows and better insulation. We've already improved so much. But homes are a lot bigger than they used to be, and so when we expand the square footage, it's just wiping out the gains that we've made. An easy way to tell how sealed and insulated your home or apartment or adventure van or whatever you live in is just by turning off your heat on a cold day and tracking how long it takes for it to cool.
When air leaks out of the house, it goes through little holes, it goes through cracks, and those things exist all over the house and in a lot of houses.
This is obviously a waste of energy and results in those harmful carbon emissions.
The older houses, half of the energy used in them or more can go to heating and cooling. Newer houses, it might be a quarter or less. Especially if you're doing something like a passive house, which is a program that requires really high levels of insulation and airtightness.
And if you were in what's called a passive house, it would stay warm for a super long time without any mechanical help.
So this mighty house we tested out building to passive house standards. I think at a small scale, this house is a really good example of what an attainable, energy efficient house can be. It's not super high tech. There's not a lot of complicated materials or techniques or methods that went into designing it or building it.
So everything about this house was carefully designed to optimize energy control. The insulation is a particularly great example of this.
This house has somewhat of a standard internal core, right? There's standard wood, 2x4 wood studs, and then there's a sheathing layer of plywood. And then there's a building wrap on it, which stopped the wind from infiltrating through the different layers. And that's all taped, so every seam is taped and sealed to prevent air from going through, and then the whole building is wrapped with this mineral wool. And then the next step is this rain screen, which is reclaimed redwood fence boards that we milled down, and then this allows the whole assembly to breathe.
Using all of those carefully selected layers prevents the heat from escaping, like we were talking about earlier.
It was like a great way for us to test all those ideas and to do it with using like the highest quality materials that were available at the time.
So if every crack in the house is sealed shut, won't it get stuffy? What about like fresh air? Well, Sienna thought of that too.
This is half of the ERV system that I'm looking at up here. Basically what it's doing is it's pulling fresh air from the outside into the building. And then the other half, which is located up in the loft, is exhausting. And these two talk to each other and they alternate so that the air is changed over in the space continually. So basically that creates a situation where if we close up all the windows, we'd still have fresh air in here.
And these solutions, sealing a house, insulating it, recovering energy, they work for bigger buildings too.
So as far as like taking these details and scaling them up for bigger apartment complexes or multifamily dwellings or that sort of thing, it's possible and really exciting to see these principles being implemented at like much larger scales, because larger buildings, larger impacts. Yeah, it's all exciting.
I don't know about you, but after all this, I have some new ideas that I can implement in my house right now and for my future dream home. My name is Niba of Notes by Niba, and this is Seeker's Impact of Everything. We're going to be talking about how all kinds of everyday things are becoming more sustainable and giving you the details into how it all works. So keep an eye out for more episodes. Thanks for watching.